Let's talk about formal charges. So formal charges are very important in organic chemistry because they're going to give us hints about where a reaction might begin, where a reaction could occur at. It's going to tell us about acidity, basicity, important for resonance. So it's really, really important that we understand what organic or what formal charges are and also be able to assign them really quickly. So to start out, just a quick definition. So you have formal charges are associated. So formal charges, which just abbreviate FC, are associated with atoms that do not exhibit the proper number of valence electrons. So remember, valence electrons, those are those electrons in the outer shell. And generally, atoms seek to have that stable octet, except for hydrogen and boron. There's a couple exceptions. But for our purposes, we're going to just talk about atoms in terms of an octet. So that's, what atoms want to have that stable octet. But for purposes of formal charge, I think it's easier to think about it in terms of the group number of an atom, which, remember, the group number of an atom is the number of valence electrons that it has. Or for our purposes, I think it's better to think of it as the group number of an atom is the number of valence electrons that it can handle. So as an example, you can say oxygen. So oxygen is group 6, so it can handle 6 valence electrons. So your question that might be coming to your mind is, well, you're saying that atoms typically need this octet. They need 8 valence electrons to be stable. Why are you saying that oxygen can handle 6? Well, because I'm talking about it in terms of the purposes of electrons that are touching it. When I start to get into examples, we'll talk about electrons touching and how that goes to formal charge. This is just a little bit of an introduction. But so just kind of as a generality, if an atom has more than its group number of electrons touching it, then it will have a negative formal charge. And then, on the other hand, if an atom has fewer than its group number of electrons touching it, then it will have a positive formal charge. Okay, so we're going to do an example that will kind of bring this all in. This is just kind of an introduction. So, for an example, and this is how we're going to assign formal charge. So we want to assign the formal charge to this guy. So the key to assigning formal charge is looking at the number of electrons that are touching the atom. So I'll just write that here because that's a really important point. Okay, so we'll start off by drawing in all lone pairs. So, let's redraw. I'll draw them in red. Okay, so just to take a step back, and so how did I know that I needed to draw in 3 lone pairs? Remember what I said about the octet rule? You want to make sure that every electron or every atom has, or at least for our purposes, we're talking about 8 electrons in the valence shell so that it can be stable. Well, remember this bond here between the carbon and oxygen is a covalent bond. Remember, that's a sharing of electrons. So one electron from the oxygen, 1 electron from the carbon, those are going in sharing, so it ends up counting as 2 electrons in the shell of oxygen. So we've got 2 electrons here to start, and now I have to add in 6 more electrons, so 3 pairs, so that I can get to those 8 electrons in the valence shell. So, our second step is we're going to want to count the number of electrons that are touching the atom. Okay, so we'll go ahead and do that up here. Let me do this in blue. So, a covalent bond counts for 1 electron touching. So, or I should say a single covalent bond. So a covalent bond is 1 electron touching. And a lone pair is 2 electrons touching. So with that in mind, we'll go ahead and count. So this covalent bond, even though it's got 2 electrons as far as our octet is concerned, when we're looking at what's actually touching the oxygen, it's only 1. And then our lone pairs, or each electron rather, counts as 1, 3, 4, 5, 6, 7. Okay, so we've got 7 electrons touching the oxygen. Okay? So then our third step is where we're actually going to assign the formal charge, is you're going to want to compare the number of electrons touching the atom to the group number of the atom. So, or I'll move over here to do that just so I can be a little higher up. So, we had 7 electrons touching, or I should say, well, you start with a group number always. So you have 6 electrons, so this was the group number, 6, minus we had 7 electrons touching the oxygen, so that gives us -1, so that means formal charge is -1. And the way we'd represent that is there, just with the negative, just the negative sign in the circle right by the oxygen. So it's really important to be able to move through these steps quickly, and you'll notice several patterns that emerge, and something which a few things you might want to look at, just a few really common patterns, and you can use this method to prove those to yourself. If you have an oxygen, this is a really common one. An oxygen with 3 lone pairs and a covalent bond will have a negative formal charge. An oxygen that looks like this, with just 3 covalent bonds, is going to have that positive charge. That's the, this is like a hydronium ion, an acid. A neutral oxygen that has no formal charge. So these are 3 really common patterns with oxygen, and then there's patterns with nitrogen also. that you can figure out with these same things, applying these same principles. And this will actually really save you time. You'll get really familiar, and you'll be able to assign formal charge very quickly.